Question 4 says a global 1D array data contains 100 elements of type integer. A function check will check the total element values in the odd index locations, so 1, 3, 5, 9, or etc. Oh yeah, well I guess 1, 3, 5, 7, 9. Total the element values in even index locations, 2, 4, 6, 8. Return one of three strings, odd, even, or same, to indicate which total is greater, or whether the totals are the same. And then we just want to write pseudocode for this function. So if you want to get this kind of starter code, of course, as always, go to exam questions, scroll down, find A levels, find this, correct paper, correct question. And if you just want to generate new data, just press this one, but let's just open this. And I'm also going to maximize the screen. So I'm just going to paste the instructions. Okay. So first then, let's just try and write the function header or the function signature, and that's going to be check. And if we look, this doesn't actually need any parameters. So let's go returns, and this is going to return, let's say something of type string. Now we want to think what local variables we need, and I guess one is just going to be an odd total, there's also going to be an even total. No, I think that should be all we need, then let's just make sure to initialize these, just to give them the value of 0, or assign them the value of 0. And I think this, there's actually a few ways we can do it. And I guess, okay. All right, so I think I'll try all of these different ways. So let's go n, and we can call it index, We can call it n. Maybe let's go index. So let's go 1 to 100. Since 100 is the length of the array. Then let's go next index. And the way we can check if a number is odd or even, for that we can just use mod. So let's go if index mod 2. If this is equal to 0, then it's even. And then if we have else, else means it's going to be odd. Because if we think, for example, 2 mod 2 is going to be 0, 4 mod 2 is 0, 6 mod 2 is 0. But then, for example, 1 mod 2 is 1, 3 mod 2 is 1, etc. So here then we just want to go even total and then just add to this. And then that's going to be, data, so data is the name of the 1D array. That should be fine. And then, here, of course, we can just do the same for the odd total. And then once we finish this for loop, then we can just have an if statement. And this will actually need to be a nested if statement since we've got 3 different possible outcomes. So I guess the first one, if the odd total, let's do this, if the odd total is greater than the even total, then we just want to return odd. And make sure just to check the capitalizations, so it's going to be big first letter, then smaller. Let's go else, and here then we're going to need another condition, so if the even total is greater than the odd total, then we just want to go return even. Let's have another else, then let's have the end if, and I guess here, this will just be, same? So I think that should work. And to be honest, I'm just gonna output the totals, just so we can see. Although, of course, in the exam, don't actually do this. And I guess, we will need to also call this. So let's go output and let's go check. Again, this is just for testing, Obviously, in the exam, you don't need to output the result. So here we see even is bigger, which makes sense. Now, let's just add something huge to the odd position. I guess like this one. Let's make it, 5,800. Now that's going to say odd. If we just make this 1, because I want to try and see the difference. So what do we need to add to this? That's going to be, 154. So if we make this, if we make that 155, maybe they're going to be the same. So this seems to work. Now, again, of course, there is another way to do that. Rather than looping through every index, 1 to 100, we could do something like this where we have step, and if we have a step of 2, and I guess really, one way we could do it is if we have 2 separate loops. So yeah, if we do something like this, right, then we just go odd total. That's going to be the odd total, then what, plus, yeah, the data index. Right, so we can then copy that. And hang on, right, so I guess here, well, we want to go, right, 1 to 99. Although in this case, actually 1 to 100 would also work, because, you know, it would get to 99, right, then it would go to 101. And of course, yeah, that would sort of fail the condition. So yeah, I mean, that loop, you know, wouldn't happen. Right, and then, I mean, let's think if we want to do the even loop, well, we can go 2 to 100 again, step of 2. And of course, we would then, let's just copy that even total. So this should also work, it should give us the same. Yeah, so if we run that, okay, it also gives us the same. And I mean, hopefully that makes sense how it's working, because, well, when we say step of 2, that means, well, the index is going to start at 1, right, but then it's going to go to 3, to 5, to 7. Basically, it's going to be plussing 2 each time of the index. And of course, you know, we can also make this, for example, like 0.5. We can also make this, I don't know, like -5, you know, yeah, I mean, that's all going to work. Like, of course, I mean, it's not going to give us the right answer for this question, but yeah, like, I guess maybe for other situations, right, you might want to do that. Right, but I mean, you could also do something similar, but if we just have it in one loop. So if we go, yeah, 1 to 99, and then what we can say, well, the odd total is just going to be this one. And then if we just copy this, yeah, maybe I should have copied the other one. Well, the even total is therefore just going to be the index plus 1. Because if we think, well, if the index is 1, right, therefore the index plus 1 is going to be 2, right, then the next iteration, well, the index is going to become 3. And then, of course, well, 3 plus 1, right, that's going to be 4. So, I mean, yeah, let's just clear that just to make sure it's working. And again, yeah, that's also going to give us the same. So I think for this one, I mean, there's, well, probably at least like 3, 4, yeah, I guess even more, you know, sort of sensible solutions you could actually use.